waiting here on the roof for this compressor to come on, and I got a friend over here. Keep getting friends. Keep getting flies and bees and crows. Whoop, he took off. One time I was working on a unit, and I was kneeling down in front of the unit, and I had my head in there and I'm working, and it was like 8 o'clock at night, and I looked up over the top of the unit, and there was a cop standing there, and he was looking at me. He was leaning forward. He was like ready to tackle me. Scared the crap out of me. I wasn't expecting that. You know, on a roof you see like a bird maybe, you know. But apparently there was a check cashing place in the next building over, and it was 8 o'clock at night, and when I came up on the roof I set off the alarm, and the cops were called. I didn't go anywhere near it, but it was just a proximity or motion sensor or something like that. But I'm waiting for the unit to kick in here. So I want to test the temperatures before and after. Okay, yesterday I put gas in, put refrigerant in the system. That was before I realized that the condenser, the evaporator coil was plugged up so bad, and it's probably the refrigerant was not expanding, and I didn't have the proper head pressures, and that's probably why I was seeing it low on gas. I'll probably have to take refrigerant out of the system today. But this is before I do any work on the system. I set up my meter. This is the air going into the condenser, and it's the air coming out. It's not very much. It's the difference is 23 degrees, and it doesn't really feel very you know, hot. It's kind of cool, and that's not good. This is another problem. These companies sometimes, they make these fan blades, and they don't throw air out this way. They throw air out this way. So when you put the fan blade on the shaft, I usually put it out as far as I can, so that the blade isn't inside this cowling throwing air back into the thing. I'm only getting a little bit of air out. That has to be worked on one of these days. But right now, my T1 on the suction line and my T2. My suction pressure is only 28, and it's R22. It should be higher. It should be like 50, 45, 50. And my head pressure should be, I don't know, 210. 240, 230. So we're gonna, my evaporator temperature, look at that. It's like -1 because it's so plugged up. It's so cold. It's just not absorbing any heat, and the refrigerant's staying cold. I'm a little surprised that the refrigerant this line isn't frosting back to the compressor. It is pretty cold though. It's frosting at the exit of the evaporator, but it's not frosting up here, so apparently it's boiling off before it gets up here. My superheat is 61 degrees, and my subcooling is 9.4. It's a TX expansion valve system. We're gonna, once I clean the coil and we start absorbing more heat, you'll see the head pressure go up, and you'll see I've got too much refrigerant in the system. Then the higher head pressure will be moving more refrigerant through the system, and I'll have to take refrigerant out, and my suction pressure will go up quite a bit. Well, that's my temperature difference right now between the inlet and the outlet, and it's just cool. It's not warm at all. Let me see. Okay, that's the air coming out is 75, 76. Okay. This is the dirty condenser evaporator coil. You see see how much dirt it's got on it. And it's restricting the airflow. It's restricting the heat going, the BTUs of heat going into the refrigerant. And what I did here was I set up, this is the delta T on the evaporator coil. I've got one probe. Here's the expansion valve, line coming off the expansion valve. I have one probe about a foot away, 10 inches, 12 inches away from the expansion valve. It's one of the feeder tubes. And the other probe is on the outlet. I couldn't get into the bulb. This is all hard as heck. But my T1, which would be this one here, it's minus 1.5, 1.2. And the inlet is 18 degrees. This is 18 degrees. So that's how cold this is leaving. This should be warm. This should have a lot much warmer. It should have some heat in it. Now I'll probably end up having to adjust the expansion valve in a bit. But now this is my inlet and outlet temperature of the coil. You can see the air going in is 36. The box is actually, it was holding temperature. As dirty as this evaporator was, it just means that compressor just running all the time. And my outlet, the air coming out of the coils over here, that's 29, but oh, I see what I did. I got this backwards. Okay. The air going in is 36 degrees, and the air coming out over here is 7 degrees. No, I'm sorry. Air going in the back right now. Air going into the coil, evaporator coil right now is 37. That's how cold this box is, and as dirty as the evaporator coil is, it's actually maintaining temperature, which is a little surprising. It just means that the compressor is running all the time, and the very low load on the compressor. The air coming out is 29 degrees. That's the temperature right here. It's 29 degrees. My superheat is 19 degrees. My suction pressure right here is 20 degrees. My temperature probe right there, I'm reading 15, 16, and this is corresponding with this 17. So it's climbing right now. I guess the valve is, the expansion valve is probably hunting, is what's happening. The evaporator saturation is minus, not good. My superheat is, I got a 20 degree superheat on this. And my temperature difference on the evaporator coil is, I got 21 degrees temperature difference. I should reverse these. But I got it, yeah. 20 degrees temperature difference, and I'm getting 20 degrees here. I have to reverse these probes. I can switch these around. But the superheat is pretty close to the delta T on the coil. Alright, I'm gonna go up on the roof and measure the pressures and temperatures right now. Okay, this is the amazingly plugged up evaporator coil. It's beer cooled. It's actually keeping temperature as plugged up as it was. What I'm gonna do is wire brush it, vacuum it. A lot of the dirt's on the surface. I used the new braid on it, coil gun, and it's cleaning it somewhat. I'm gonna try some Ace. Wash this out and put some Ace on it. See if that does a little better. Well, I put some of this Ace foaming on it, and it worked much better. It's dissolving the foamed up on this half of the coil. Foamed up much better than the new braid did. It's probably had a little bit of oily film on it too. Probably the new braid wasn't good for the oily film. But it's just eating it away right now. I'll turn the fans on and suck it into the coil. It's getting sucked into the fins now. Of course, this fan isn't working here. But then I'll wash it out with water. My Testos all the way down there. Oh, they're pretty good. The Testos are durable though. Bucket's about full. Better change the bucket. Okay, I dumped that bucket out. It was black. The liquid in it was just black. And this is the Ace foam. It's doing a much better job. I used a can down there and a can on this side. Plus the I put the first used the new braid on it. That probably helped, etched it a little bit, cleaned it a little bit. But the new braid's, this Ace is working much better though. The new braid in the can might have worked better. But yeah, made a mess everywhere. Well, it definitely looks cleaner now. I'm sure air will pass through it pretty good. I suppose you can see the light through it, but it's definitely clean now. Good for another 5 years. Some of the fins are getting a little bit flaky here. It looks good. And Always wear protective glasses. That's important, especially when you're splashing all this solution around like that. Okay.